Hi, AP Stats kids. I'm really bummed that I don't get to see you for this lesson because this is my favorite lesson to teach. So the goal for the next 2 days for you guys. So tomorrow is 1:30 and then we have 1:31. I want you to ignore these dates on the side, but I just want to give you a brief overview of what you need to get done for the next 2 days while you guys are home. Okay, so I'm going to give you notes all in one video. So it's going to be a long video, so kind of pace yourself. First things first, I'm going to go faster than I normally go teaching. So stop yourself where necessary. Write any notes or questions that you might have. I'll be available by email and I will get back to you during the day, sometime tomorrow, as well as the next day. Okay. So the notes that I'm going to give are 3 slides and it will take some time over 9.2a and 9.2b. Now, unfortunately, because you're not in school, I don't have the printout for you. Those are located in Schoology. Those worksheets you do need to work on while you're home for the next 2 days. Okay, they're located in Schoology. Use them as a book assignment and you will need to rip them out. So please don't come to me with like your book and say, can you just check this off? You're going to have to rip them off and turn them into me. If you have a printer, feel free to print them off. Here's the goal for the next 2 days. I'm going to suggest that you watch the video on Wednesday and then on Thursday work on the assignment. All right, you guys ready? Let's get going. The first problem we're going to go through is a one sample z-test for P. This is a one-sided test. I'll talk about the difference between a one-sided test and a two-sided as we go. I will give you these problems as a handout that you can glue in. So if you want to leave some space to glue that in, you can. If you want to pause it and just write it all down, you can do that as well. All right, let's get going. According to the National Campaign to Prevent Teen and Unplanned Pregnancy, 20% of teens aged 13 and 19 say they have electronically sent or posted sexually suggestive images of themselves. The counselor at a large high school worries that the actual figure might be higher at her school. To find out, she gives an anonymous survey to a random sample of 250 of the school's 2,800 students. All 250 respond, and 63 admit to sending or posting sexual images. Carry out a significance test at alpha equals 0.05 significance level. What conclusions should the counselor draw? All right, so let's get going. For the state part, what do I want? I want the parameter of interest, the null hypothesis, and the alternative hypothesis. So I'm going to start right away with that parameter of interest. You have to decide what am I dealing with? Am I dealing with a proportion or am I dealing with a mu? Okay. Well, how do you know? First things first, you don't see anything about average in here. Second thing, you have parts of a total admitting to something. That's a proportion. Okay. So P equals the true proportion of teens at this school, not Armstrong, at this school that we're talking about in the problem. I want to be clear about that. Okay. The true proportion of teens at this school who admit to sending or posting sexual images. Can I just put images? I'm just going to put images. Okay. Oh dear. Forgive me. I'm going to put posting bad images. There we go. All right, so we've practiced this step before, writing the parameter of interest, right? And, okay, so step 1, in the states, we want to do our parameter of interest, our null hypothesis, and our alternative hypothesis. Our parameter in this case for all of 9.2 will be P's, okay? Our null hypothesis, what that is, that's going to be like the status quo or the truth as we know it, or some kind of claim. So right now, HO, P is equal to, and we want to say, well, what is the claim right now? The claim or the status quo right now is this 20%. 20% of teens say they have electronically sent or posted bad images of themselves, sexually suggestive, when I say bad, okay? So in our null hypothesis then, we're going to put P is equal to 0.20. I'm not going to put 20% because we never do that in stats. We never put like 20%. Everything's always written as a proportion or decimal, okay? Then HA is then what are we trying to prove? Well, this counselor thinks that it could be more than that, right? Where does she say that? She's worried that the figure might be higher. Okay, right there she states it. So we're going to put P is greater than 0.20. Okay, so now we have a sample right here. Here's 250. That's our sample. That's part of our sample. So 63 divided by 250, that's our P hat. We're not going to worry about that quite yet. I just want to make sure that you guys know exactly what I'm looking for in the state step. So in the state, I want the parameter of interest, the HO, and the HA. Okay? All right here. 1, 2, and 3 points for that state part. Write down any questions you might have, and now let's move to the plan part. In the plan part, what I'm looking for is the conditions and the method. Our acronym stays the same. We have RIN. And our method now will be something a little bit different. We have been dealing with one sample confidence intervals for P or mu. Now we're going to change that. Let's start with the conditions though. Random stands for our R. Do we have a random sample? She gives an anonymous survey to a random sample of 250. So it does say that. Stated random sample 250. I stands for independence. That's our 10N rule. So write that over on the side if you've forgotten. 10N has to be less than capital N, our population. So our N is 250, which we state right up there. 10 times 250 has to be less than all students at the school. Well, do we know how many students are at the school? We do. There's 2,800 total students. And that's correct. Okay, so we're okay there. Okay, we are okay. So 2,500 is less than 2,800 total students. Our independence condition checks out. Friendly reminder that our independence condition is tied to our standard deviation. That's the reason that we can use the standard deviation that we do use. And then finally, our normal condition. And our normal condition is either N is greater than or equal to 30, or our NP has to be greater than or equal to 10, and our N times 1 minus P has to be greater than or equal to 10. How do we know which one to use? Well, since we're dealing with a P, we're going to use NP. Let me type it over here just in case you've forgotten. NP has to be greater than or equal to 10, and N times 1 minus P has to be greater than or equal to 10. So let's do that over to the side. Our N is 250. Now, do we know our P? In our confidence interval, we didn't know our P, so we had to use P hat. But in our significance test right here, when we do a null and alternative, we do know our P. So we do 250 times 0.2, and that is greater than or equal to 10. And then 250 times 1 minus 0.2, and that's greater than or equal to 10. So we're okay to use that normal condition. And the normal condition is tied to our normal distribution, meaning we can use that z-score and find a p-value. Now we have our method, okay? Our method is a one sample z-test for p. This you have to memorize. Our conditions are met. This is our method we're going to use. It's like if you go to the doctor, they have to check your knee out. They say, yep, you meet the requirements for this type of surgery. Okay, this is the method we're going to use. All right, moving on now to the do part. I already have the do already filled out. And you know what? I'm going to pause the video and I'm going to actually not do that. I'm going to erase it. Okay, so I had it all filled out and I was going to talk through it this way, but I think it would be more helpful if I actually go through the problem. So in the do part, what am I looking for? Well, I'm looking for a z-score and a p-value. That's the biggest thing. But how do we get here and what are your insurance points in case you make a mistake? So we know right now that we're going to use the normal distribution. We've already met that condition. Well, our mean, what is our mean going to be? Our mean is our center, and our mean is always going to be whatever that HO is, okay? In this case, our HO is a P, so it's going to be a P equals. We're not going to write down HO. This is just a reminder so I know, well, what is my center going to be? And it's whatever that null hypothesis is. We assume that to be our center right now. And then our standard deviation, well, what is that going to be? Well, I want to remind you about your formula sheet, okay? When you're questioning what should my standard deviation be, always go to this page and you look and you say, okay, what am I dealing with? Am I dealing with one sample, which is right here, or am I dealing with two samples, which is right, hold on, you can't see my cursor. Am I dealing with a one sample, or am I dealing with two samples? And we haven't learned the two sample yet, so we are only dealing with a one sample so far. Then you ask yourself, am I dealing with a mean or a proportion? I'm dealing with a proportion. Here's the formula for my standard deviation. Okay, so going back, oops. I'm going to write down that standard deviation that I need right here. That standard deviation is the square root of p times 1 minus p over n. What else am I going to put on here? Well, I'm also going to mark what my p hat is going to be. And then I'm going to shade. How do I know what side my p hat is going to be? Well, easy. Just calculate it and you'll see where it should go. It's always, and another way you'll notice when things are greater than, it will always be on the right. When things are less than, it will be on the left. Okay, then what else do I need? I need a z-score and I need a p-value. So let's actually put this into practice right now by drawing our curve. We know that our p is equal to 0.2. How do I know that again? That's what my null hypothesis is right here. Next, I'm going to find my standard deviation. My standard deviation is 0.2 times 1 minus 0.2 divided by n. Well, what is my n? I already said that I have a random sample of 250. I'm now going to calculate that in my calculator, okay? So I'm going to take 0.2 divided by, or I'm sorry, 0.2 times 1 minus 0.2, so 0.8. I'm going to divide it by 250, and then I'm going to take the square root of that. And I get 0.0253. Okay, so what did I say I need? We need our null hypothesis, we have it. We have our standard deviation, we have it. Well, now we need our p hat. Remember, our p hat is always going to be part of the total. So here's my x, my parts, and here's my total sample. P hat is always x over n, okay? So we're going to take 63 divided by 250. When I take 63 divided by 250 in my calculator, I get 0.252. And now I'm going to shade this way. Okay, so right now this 0.252 is bigger than 0.2. So this counselor has evidence that it is higher at her school. The question is, though, is it significantly higher? So what do? We have to find a z-score. What's our z-score again? Just a friendly reminder, ZOMS. Z is equal to what we observed. We observed at 0.252. Minus our mean in this case is 0.2, divided by our standard deviation. You do not need to rewrite our standard deviation out when we already have it written out right here, so I'm just going to put divided by sigma. I'm now going to type this in my calculator. 0.252 minus 0.2 divided by 0.0253 gives me a z-score of 2.06. Okay, friendly reminder, with a z-score, you only need to round to the nearest hundredth. Well, now I need to find a p-value that goes with that. So a lot of my class from first semester, they know how to use their calculator to do that. But in case you don't know how to use your calculator, you can go to your formula sheet. You go to your z-score of 2.06. Okay, so 2.06 is 0.9803. .9803. And now because I shaded to the right, because we are dealing with a greater than problem, right? Our alternative hypothesis is greater than. I'm going to do 1 minus 0.9803. And when I do 1 minus 0.9803, I get a p-value equal to 0.0197. Okay, and now we have that p-value, and you guys should know how to conclude. I'm going to go through it with you because I want it a little more sophisticated now. I'm going to pause it real quick and type it up so it looks a little neater. Give me 1 second. Oh, if I can find it. Okay, we've already practiced concluding based on a p-value. Now, what I want to do is I want to make it just a little more sophisticated. Our first sentence, we need to make a decision, right? We need to talk about our p-value. So I'm actually going to state what my p-value is. Because my p-value is approximately 0.0197, now I'm going to make my decision. I lied. I'm going to stick to the same thing. Give me 1 second. Sorry, I don't want to redo everything because I've been taping for 16 minutes now and I still have more to go. So give me 1 second. Okay, I just paused it and rewrote something because I want to stay consistent with what we've been doing. So we want, in our first sentence, we want our p-value. We want to link it to alpha. How do I want to link it to alpha? Well, because my p-value is approximately 0.0197, which is less than alpha equals 0.05. Now, what is our decision going to be? We reject the null hypothesis. That's our first sentence. How has this changed from our one from section 9.1? Before we just said because my p-value is less than alpha, we reject the null hypothesis. We did not fill in these numbers here. I want you to start doing that to get more sophisticated now. 9.1 was designed so you understand just how do we reject, how do we fail to reject. Now I just want you to get more sophisticated with that sentence. Hopefully everyone understands. If you don't, we'll have time on Friday to go through questions. Okay, so first sentence done. Second sentence, we either have evidence for or against HA. So because we rejected our null hypothesis, we have evidence, okay, for HA. So we have evidence that the true proportion of teens at this school who admitted to sending or posting bad images is greater than 0.2. So I have evidence for HA. I just need to make sure that it is in context. We have evidence the true proportion of teens who sent images is greater than 0.20. Okay, second sentence done. In a nutshell, how do we decide? Again, we wrote this down already, but if our p-value is less than alpha, we reject our null hypothesis. That's our first sentence right there. We have evidence then for HA. If our p-value is greater than alpha, we fail to reject our null hypothesis. First sentence, we have no evidence for HA. I'm going to actually stop the video right here, and this would be like one of your 2 videos you'll have to watch. You have enough information to start section 9.2a homework if you want to kind of break things up a little bit.